Hi everyone, welcome back. Today we're starting with the first part of Unit 2. So Unit 2 is Intro to Functions. This is a new word we'll learn soon. And proportional relationships, which you saw in 7th grade. So it should be a little bit of review, some new stuff, and yeah. So today is representing proportional relationships. So the objective today is students will be able to represent proportional relationships using tables, graphs, and equations. So we'll see how to get a relationship from a table, a graph, and an equation. Today, I have a quote from the movie The Cat Returns. It's a 2002 movie from Studio Ghibli, really good, highly recommend. So in the movie, there's a quote that says, "Always believe in yourself, do this, and no matter where you are, you will have nothing to fear." So some nice inspiration for today. Believe in yourself, and everything will be okay. So let's start with my first example. So in high school, I taught swim lessons. It was so fun. It was such a fun job. And the table below shows how much money I made after working a certain amount of hours. So after 1 hour, I would make $8, 2 hours, 16, 3 hours, $24, 4 hours, 32, and we'll figure out what these numbers are in just a second. So let's answer this first question. What relationships do you see among the numbers in the table? So I look at this table, and first I see that my hours are going up by 1. My money is adding 8 each time. So I add 8 each time I go up an hour. So I can use what I know from here to determine how much I will make in 5 hours and 6 hours. So if I'm adding 8 each time, and 5 hours, I would add 8 from 32. So 5 hours, I would make $40. Add another 8, and for 6 hours of work, I would make $48. So 6 hours, 4 to 6 hour shift was pretty common. So if I worked for 5 hours, I'd make $40, and I would do that a couple times a week, and the money adds up. Not too bad for high school. So so we see a relationship where we're adding 8 every time we go up an hour. So let's take a look at some other questions. So for each row in the table, I want to find, hold on, I don't know if you can see this. I want to find let's move this here. I want to find the ratio of the money Miss Ewell made to the number of hours she worked. So this word ratio, maybe we haven't seen it in a while, but this word ratio, remember, is usually written like a fraction. Sometimes you might have seen it with colons, with a colon like this, but we're going to write our ratios as fractions. So I want a ratio of the money I made to the hours. So down here I have money over hours, and I want to write this for each hour. So I have 8 over 1, so $8 for 1 hour, $16 for 2 hours, $24 for 3, 32 for 4, and 40 for 5. Now this says to write each ratio in simplest form. This is going to make it easier for us to look at these numbers. So my first one, money over hours, 8 over 1, that simplifies to 8, right? Anything over 1 is itself. 16 over 2, 16 divided by 2 is also 8. 24 divided by 3, that's also 8. And what do you think? 34 divided by 4, that's also 8. 40 over 5 also simplifies to 8. So what do you notice about the ratios? They are, in fact, the same. So my ratio between money and hours for every single point here, every single row is the same. My ratio is 8. So let's kind of pull this all together. So in the table of a proportional relationship, so that's kind of one of our key words for today, proportional relationship. there is always some number that you can multiply by the number in the first column. So my first column is hours, to get the number in the second column. My second column is money. So what was my number that I can multiply? The number I found in the previous slide was 8. So if I multiply the number of hours times 8, I will get how much money I'll make. So 1 times 8 equals 8. 2 times 8 equals 16. 3 times 8 equals 24. And 4 times 8 equals 32. And 5 times 8 equals 40. So this number that I multiply each number by is called the constant of proportionality. Last year, you might have learned a letter that we use for this, a letter, and that letter is K. So the number that we multiply each of these numbers by to get this number is 8. We call that K, the constant of proportionality. So our K here equals 8. So my constant of proportionality, so I multiply 8 by my hours to get the amount of money. And this makes sense because I'm making $8 per hour. So $8 for 3 hours is 24. $8 for 4 hours is 32, and so on. So this is how we get the constant of proportionality. So to get the constant of proportionality, we do finding the ratios, the simplified ratios, and then that's our K. Let's look at another example. Let me move my base. All right, here's another example, and this graph shows the relationship between the weight of an object on the moon and its weight on Earth. So, you know, if you ever go to the moon, the objects are gonna weigh they're gonna weigh a little bit less because of the gravity. I'm not a scientist. So here's my Earth weight on my x-axis. We're going to be seeing a lot of graphs in this unit, so we'll get used to reading our graphs. My x-axis label is Earth weight, and my y-axis is moon weight. And the graph of a proportional relationship will always pass through the origin 0, 0. So here is the origin 0, 0. It's in the middle of like the x. And this question asks, does this graph represent a proportional relationship? Well, my line certainly will go through 0. It starts at 0. So this graph does represent a proportional relationship. And next we're going to look at each of these points. So now we need to remember our x, y coordinates. So we want to find our constant of proportionality given this graph. Let's make a table of this graph so then we can look at our ratios like we did with the swim lesson example. So what we need to do is make a table of the graph. So let's figure out what each of our points are first. So this first point, I'm going to look at x, comma, y. Remember, x goes this way and y goes up and down. So this point right here, this first one, I'm over 6, so my Earth weight is 6, and my moon weight lines up with 1, so this is 6, 1. So let's write this in our first, sometimes tables can be horizontal like this, so we're going to write this in our first column. So in our first column, we'll put my Earth weight as 6, and my moon weight is 1. Let's look at the next point. Earth weight is at 12, and my moon weight lines up with 2. So Earth weight, 12, matches up with moon weight of 2. This next point, my Earth weight is 18, and my moon weight is 3. So 18 Earth weight matches with moon weight of 3. And my last point, my Earth weight is 30. That's my x value on my x-axis. And my moon weight is 5. So 30 matches up with 5. So now I have my table of values. And I can do find my ratios and find the constant of proportionality. So I want my moon over Earth to be my ratio. So I'm doing my y-axis over my x-axis. So this is y over x, my y coordinates over my x coordinates. And I can match these up too and say that Earth weight is on my x-axis and moon weight is on my y-axis. So my moon in my first one is 1, matches up with 6 Earth. And then I have 2 over 12, 18 over, 3 over 18, and 5 over 30. Now let's simplify. 1 over 6 is as simplified as that'll get. 2 over 12, I can divide both of these numbers by 2 to simplify. So 2 divided by 2 is 1, and 12 divided by 2 is 6. I think you can see where I'm going here. 3 over 18 simplifies to 1/6, and 5 over 30 also simplifies to 1/6. So this is my common ratio between all of these values. This is the constant of proportionality. So my constant of proportionality is 1/6. Let's write an equation now for this. So I already said earlier that x is my Earth weight. Right down here I have x, Earth weight. I have my y, which is my moon weight. And we found our constant of proportionality, which is k equals 1/6. And I just want to write an equation that models this. So we found k in the last slide, and we're going to put it into this form, y equals kx. So my k is here, and I can write y equals 1/6 x. And this equation models this relationship. I could also find k by plugging in one of my points in and solving. So one of my points is, let's see, where y equals 1 and x equals 6. I could say 1 equals k times 6. And now if I solve for k, divide both sides by 6, then k equals 1/6. So that's another way to find the constant of proportionality. But this equation models our situation. Let's just wrap things up really quick. So I can represent proportional relationships with the table. Here's my constant of proportionality, 5. I multiply all my x values by 5 to get the y values. 1 times 5 is 5, 2 times 5 is 10, 3 times 5 is 15, and 4 times 5 is 20. Here's a graph. We know that this graph represents a proportional relationship because it passes through the origin, which is 0, 0. And we can also write an equation using our constant of proportionality where k equals 5. We found that from the table. And we can just plug it in for our k here. Y equals kx. So y equals 5x represents this graph. So I can, if I use a graphing calculator and plug y equals 5x, this is what the graph will look like. And if I use any of these values, if I put 5 in, if I do 5 times 1, I'll get my y value, which is 5. If I do 5 times 2, I'll get 10, which is my y value, and so on. So all of these are just different ways to represent proportional relationships. So I'll see you next time for slope and rate of change.